Now that we've talked about substitution, let's talk about a second method for solving systems of equations known as elimination. It may not always be ideal to use substitution. Like I said, we usually want to solve for a variable that has a coefficient of 1, but in this equation right here we can see that we don't actually have one, and we may have to introduce fractions very early on, and we don't really want to do that if we can avoid it. So let's avoid it. Elimination method is also sometimes known as the addition method, because essentially what I'm going to do is add these two equations together. When I add them, negative 4x plus 4x is 0, negative 2y plus 8y is 6y, and negative 12 minus 24 is negative 36. And you can see immediately that we actually got rid of x, and this is why it's called elimination method. I actually eliminated the variable x. Dividing then by 6 would give me that y is negative 6. And now we need to find x. And essentially we can use either one of these equations to find x. I'm going to do the first one. This is negative 4x minus 2 times y, but we now know what y is negative 12. Well, negative 2 times negative 6 is positive 12. And then I can just solve a linear equation. Subtracting 12 from both sides leaves me with negative 4x minus 24, and dividing both sides by negative 4 gives me that x is 6. So my solution, 6, negative 6. Here's another example, and while we could very well use substitution on this method, we could also use the elimination. Adding them up, x plus 2x is 3x, negative y plus y is 0, and 11 plus 19 is 30. Dividing by 3 would then give me that x is 10. In order to find y, this time let's use the second equation. No particular reason why other than we used the first equation on the last example, so let's change it. We have 2 times x, which we just said was 10, plus y equal to 19. So this is 20 plus y equal to 19, and subtracting both sides by 20 gives me that y is negative 1. So I have my answer 10, negative 1. Now let's look at this example. This one's slightly different. In the last examples, whenever I tried to add the equations together, one of the variables was eliminated, but here it wouldn't be. I would end up with a 15x minus 6y equal to negative 9, and that doesn't seem any simpler than what we have right now. So instead, occasionally when we use this method, we're going to have to multiply by a number. And in this case, we're going to have to multiply one of the equations by a number. And maybe we have to multiply both, but essentially I want things to cancel. So the first step is to pick which variable we want to cancel. Let's try to eliminate the x. So I have a 5x and a 10x. But if I multiply this top equation by negative 2, I would then have negative 10x minus 2y equal to minus 18. If I leave my bottom equation alone, then I'll notice that when I try to add them up, I have negative 10x plus 10x, which is, when I add these equations up, negative 10x plus 10x is 0. Negative 2 minus 7y would be negative 9y. And negative 18 minus 18 is going to be negative 36. So when I divide by negative y, I get that y is 4. Now we need an equation to figure out what x is. Let's use the first one. That says 5x plus y, which we just said was 4, is equal to 9. Subtracting 4 from both sides gives me that 5x is equal to 5, so x is 1. I have my answer 1, 4.